Welcome to TVUG for March 2021. Our presentation will be on C# 9 and beyond, presented by Mads Torgersen. We're always looking for speakers for TVUG. If you'd like to do a presentation, please reach out to us at meetup.com/TechValleyNetUserGroup. TVUG is sponsored in part by the .NETFoundation.org. Looking for other user groups to attend? Please visit meetup.com/.net-virtual-user-group.
Let me just get started then. So for those of you who might not know me, I'm Mads Torgersen. Nowadays I'm the lead designer of C# over at Microsoft, and that means whenever you're frustrated by some of the new features that come into the language, I'm the one you should be shaking your fist at. If there's something that's missing that you're annoyed about, I'm the one you should be shaking your fist at, or alternatively letting me know very kindly. So as far as I can see from today's invite, we have about 2 hours minus the 13 minutes we're in. Is that about right?
So yeah, you have as long as you want.
As long as I want. Well, why don't I aim for until until 8 p.m. Eastern with material, and I'm certainly game for hanging around longer. But it's nice to have a time point to steer for in terms of getting material across that that you can also plan around a little bit. So let's try to get through the presentation in that amount of time, and then I'm happy to stick around and chat longer. It'll only be 5 p.m. here, so I won't even be hungry yet for dinner. So it'll all work out just nicely. I really want for this to be a conversation and not so much a presentation. If you guys don't say anything, then we won't make it till 8 p.m. So I really hope that you can either in chat or in particular just by unmuting yourself and asking. I'm happy to take a bunch of questions. And if I kind of get carried away and folks are asking questions in the chat that I'm not answering, somebody can just unmute and tell me to get with it. I'd rather stop when we're talking about a given topic and discuss it right there and then, rather than wait to some Q&A slot later. So and we can pretty much go anywhere, but what I brought today is a demo of the C# 9 that came out, 4 months ago now, and some of the features there. And I'm going to try to, since we started now in earnest working on C# 10, I don't have any demos yet. We're not quite there. That'll be at build a couple of months from now. But we can certainly talk about some of the features that we're thinking about for C# 10, which is coming up in November of this year. So I'll try to sprinkle some of that in if we're touching on that topic anyway in the C# 9 demo, and just say, oh, and here we're thinking about something for C# 10 as well. And we can also have some slides that we might go into, at least for some of the topics, just to show some syntax. So with that, let's start diving in. So about 4 years ago, we decided we're an adult language now. We need a strategy. That was about when we turned 18. And so we decided to be adults and have a plan for how or put to words how we think about essentially C#'s evolution, our investments in C# going forward. And we shared that out at that link down there. And it still pretty much holds 4 years later, which kind of validates that it was indeed a strategy and not a tactic. So it's sort of like, it's longer than that, but there's sort of 3 core elements to it. The first one is very much about the sort of aggressiveness, if you will, the steepness of the curve of C# language evolution, which is that we will aggressively evolve and innovate in C#. So we want, even C# is certainly a mainstream language and it's being used for many things, but we want to lean into addressing new scenarios well. and also learning from the general evolution of the state of the art of programming languages. So we err on the side of adding more new features rather than less, even as we try to be judicious and not put things in that will turn out to be a passing fad or that won't prove their worth over time. Of course, we can't know, but we try our best. But that said, we will take the hit of growing the language, making it bigger, putting more features in, for the sake of having a language that's more productive and more applicable to the scenarios of the day as that evolves. At the same time, being a mainstream language that is used for an incredible amount of different things, like the number of different scenarios where C# is used by tens of thousands or hundreds of thousands of people that's just staggering. And so we really have to try to think about the benefits, having a benefit to all C# developers. And there's sort of like, actually recently, Jared Parsons gave an internal talk. He's he manages the compiler team for C#, and he roughly groups C# features into 3 buckets. And it might be useful to talk about this point in that light, where there's one bucket is productivity enhancements. It's like the feature just makes life better for you with respect to a particular scenario or coding in general. There's what he calls divisional initiatives. I don't know if divisional is the right word, but it's the generally a theme is being pushed on in the .NET area at large, and the language plays a role in it. And of course, we will then go and say, okay, we'll do this feature now because it fits with what else is going on up or down the stack, from tooling, libraries, language, runtime. We'll definitely play in a space there so that we can so that the different layers can enhance each other. And then the third kind is performance enhancements. And we've done quite a lot in that space as well. And that it's often the case that we add a C# language feature that is kind of low level, and that doesn't benefit a C# developer directly, or most C# developers directly, because they would never use the feature. But it helps write safe, efficient code at lower levels that will then benefit you when you use that API or slot into that framework. So we've seen a lot of leverage on this front, and working together with the rest of the stack, we've seen very, very important, like very significant improvements to performance over the last half decade in particular. Then there's a focus on the community aspect of C#. It's an open source language. It not just the implementation, like the compiler is being developed in the open, but the language is also being designed in the open. So we have a GitHub site for C# language design. We can go and look at it later if you feel like it. So we are very happy that we can now have a very fine-grained day-by-day dialogue about the direction of the language, that all proposals are open, that the progress on the proposals is always visible, and everyone can influence it, and there can be a discussion. We can get a lot of course correction that we couldn't get in the old days when things were closed down and only revealed, when everything was set in stone. So that is, that is probably the main reason why someone like me can be the lead designer of C#. I get a lot of course correction. I don't have the legendary intuition of someone like Anders Heilsberg, who could sort of just almost infallibly tell how a given feature or a given design would be received. I don't have that magic skill. So it's really necessary for us to always have to be able to tack to the feedback and understand whether we are heading in the right direction. So we get a lot of community influence, but at the same time, we're also very conscious that there needs to be strong stewardship of a language like C# that is relied upon by many critical industries and so on, that people bet their lives on C#, or certainly their livelihoods, and we can't just let it drift around or let it be designed by committee or kitchen sink or whatever. There has to be sort of strong leadership and stewardship where we say, okay, this feels like C#, this does not feel like C#, this feels important, this does not feel important, and make, have a body of people that that makes those calls. And that's the C# language design team, which consists of me and about a small dozen of other people who spent significant amounts of their work week thinking through and massaging the C# designs and deciding ultimately what goes in and what doesn't go in. So so try to balance that very broad community engagement with quite strong stewardship of where the language eventually is heading. So that's pretty much what I had to say about that. And at this point, I'm curious. Now you're sort of, most of you have made it in and settled into your chairs or whatever you're sitting on or standing on out there. Curious if at this point there are questions or thoughts or anything, either in the comment section or in the chat or verbally. Pause for effect.
Yeah, if anyone has a question, this is you can always post it in the chat channel or click the raise hand indicator.
Yeah, I have a comment on the evolution of the language several years ago. We were sort of pioneers in using the .NET framework for some critical real-time systems, and the removal of some of the unsafe constructs from C# kind of harmed that whole effort. We had to end up doing a lot more things through interop. I don't suppose there's anything you can do about it now, but just as a comment, that did negatively affect some people.
So that's interesting. I probably don't fully understand where you're getting at, because we never actually removed anything from C#. That just never happened ever. So there's still unsafe code in C#, for instance, and everything that was allowed at the language level was before. Is this about the switch to .NET Core and some of the things that went away in that?
This happened a long time ago. I think it was from 2.0 up to 3.0. Some of our tests just stopped working, and we were unable to use certain of the unmanaged constructs.
Interesting.
I don't remember well enough to be specific about what they were, but there was another huge hit to all of our real-time work when the framework went from 1.1 to 2.0 because they took out one critical instruction, IL instruction, which we're using all the time. There was an instruction that allowed you to write directly into the data bytes of a box. And someone thought that was a security hazard, so they took it out.
That's interesting. So we are way back with where I might not even have been around when that happened. But I think that, so we try very hard not to do that kind of thing. Maybe we were a little more Wild West back then. And I sort of retroactively apologize, because this is the kind of thing that we want very strongly to avoid now. Like we at the language level in particular, we have never yet retired a feature. It's simply something we don't do. We might, this doesn't even happen a lot, but we might gradually sort of discourage the use of a feature. You could even probably imagine that the tooling support around it would be less good, that it would have less refactorings or something like that. But all the features of C# all the way back, except maybe some stumbles we did in the beginning there where we weren't quite settled on that policy yet, they remain there, because otherwise we start breaking people's code, and we don't want to do that. That's sort of like imperative number one, is don't break people.
Did you ever know Serge Linden?
Not.
He's the author of The Assembler. And if you read his book on IL version 2 for the ECMA version 2 that .NET that Microsoft implemented, he screamed bloody murder about the removal of that one instruction.
Okay. Yeah.
Against
Well.
his best advice.
Hey, Mads, we have a question from Alex. He was asking about mix-ins.
Yes. Well, Kurt, just to round it off, sorry about that, but yeah, so this is definitely something we try not to do again, and precisely because people get hurt so hard when we try to do that. But to Alex, like mix-ins, just to change over to that subject, well, mix-ins are a language feature that kind of it means slightly different things to different people, but the essence of it, I guess, is it's typically a mix-in is a little bit like a class. It's behavior that you can inherit, but mix-ins tend to not have state, and on the other hand, they tend to be able to be mixed in with multiple inheritance. Like there's sort of extra stuff. You can have your inheritance hierarchy of classes, and there are extra stuff that you can pull in on the side. And we've looked at mix-ins a couple of times as whether they had a future in C#, and we've generally felt that it would be doable with sufficient runtime, like expensive runtime modifications, but we haven't really found sort of the killer scenarios where we felt like this would really solve a lot of problems. So we haven't done it. We do approach mix-in-like behavior a little bit in interfaces nowadays. As you know, interfaces can be multiply inherited and implemented. Like an interface can inherit multiple other interfaces, a class or struct can implement multiple interfaces. And with default implementations in interfaces now, there's a little bit of an effect where if you use default implementations from multiple interfaces where you don't give them those members and implementations in your class, but just inherit those default implementations, then you have a little bit of a mix-in effect. So some of the semantics in there, but it's not really that's not really the key scenario for that feature. So, and it's something for now, I think we've decided to leave it at that. It hasn't really been imperative on us there hasn't really been this big set of user scenarios that motivated us to take on the complexity that mix-ins often lead to. One of the things you often see with mix-ins, for instance, is the inheritance is order dependent. Like inheriting from A or mixing A in A and B is different from mixing in B and A, and that's how they deal with some of the clashes that can easily occur in a multiple inheritance-like scenarios. And we avoid that in C# today, and we would like to keep avoiding it, that order dependence. All right.
Great, thank you.
With that, I want to just actually let's flip out of slides and just hop on into Visual Studio. With this, I'm going to start focusing on some of the C#9 features that we've done. You've probably seen some of them before, but that's what I'm able to show you. That's what's there. So I'm sorry that you're late in the C#9 cycle, but then again, maybe you can get some fresher thoughts on C#10 if you ask me the right questions. So hopefully we'll make up for that. So apologies if you've seen the demos before, but by now they're well worn, and they fit me like an old pair of pants. So I'm going to go through them one last time here. One of the things that we feel, here's a little program, right? There's a couple of classes and a main program. It uses the classes. There you go. One of the things that is happening in the language space is not so much about deep innovation, but about languages generally becoming less verbose. The modern languages of today, they have snappier, terser way of saying things, and we get a little bit of envy on that, and we feel like in comparison, many things in C# are a little heavyweight to do. Like they require more ceremony than maybe they should. That was all fine 20 years ago, maybe 10 years ago, but maybe it's not so fine now. So we're sort of in a running effort to take the worst offenders here and try to clean things up. So one of the things that C# is now a little alone with is that in order to write a program, like in order to write some statements that do some stuff, you have to stick them in these 2 layers, at least 2 layers of indentation, 3 if you have a namespace as well. And that's kind of just, if you're a beginner, that's just like, that's a lot of boilerplate that has to be around for you to write hello world. And even for the rest of us who've been writing for a while, it's just unnecessary boilerplate to put around your main program. So so we decided, hey, let's just let you get rid of this. Let's let you write a main program that's not nested inside of a method, nested inside of a class, but that is really just statements at the top level, right? So pick a file in the file where you have your main program and just stick the main program on top here, right after the usings. That is now valid C#. So if you're teaching someone C#, now that's a whole bunch of stuff you don't have to tell them to ignore. And if you're writing C#, that's a whole lot of goop and indentation you don't have to deal with. So we think that's just one of those ways that we make C# a little more approachable. Any comments or questions on that one? It's a quick one.
Yeah. Sometimes when you make a language more and more terse, or being capable of being written in more terse terms, it harms the ability to train junior programmers, because sometimes it's better to spell things out. And we do a lot of training of teams. So we avoid doing everything by link when it's possible, and write it out so that the younger, more junior people can get a little bit better handle on what's going on. And that's been an ongoing concern with other languages as well. So there is a trade-off there.
Yeah, there's definitely a trade-off, and I think there's a difference between introducing a shorthand that is, like, sometimes shorthands can be obscure, right? And sometimes we've shied away from that. If you think about auto properties, for instance, in the beginning, like auto properties are a shorthand, and you kind of have to understand what they get expanded to. So there's like a deeper truth underneath, and we have to use that kind of thing sparingly, and where it's like where we would expect that shorthand to be in very common use. This here, though, seems more like a simplification. Like if you come to C# now, in C#9, you never need to know that, except for reading old code, I guess. You never need to know that or understand that there's a way that you can write your main program that's tucked away in some method with a specific name in some class. This is just a simpler way of writing a main program. This just makes the C# experience simpler, not just shorter, but simpler. And I think that's that kind of thing we feel really good about. But that's it.
Yeah.
So that said, we don't shy away necessarily from the other kind, where we're introducing a shorthand for something that's very common. Yeah, and that kind of goes to the philosophy of C# again, that we would rather make life better for the professional or semi-professional developer, like give you sharper tools, sometimes at the cost of adding some complexity to the language. It definitely has trade-offs, and we kind of err a little bit on the side, not like C++ style on the side of complexity, but we do sometimes we embrace giving you more shorthand for even though it adds another way of doing things to the language.
You have to keep in mind that the kids coming out of college now, they're not at the same starting point that us very experienced people were when we came out of college. So taking the structure out of this they already do this in Python in college. So they're not losing anything by not having it there. They're used to that.
I think that's a very good point. And that's that thing again about keeping up with the evolution of the state of the art here. Like back when C# came out, people were just starting to learn a lot of Java. And in Java, this was how the old C# way was also how you did it in Java, right? I think we stole it from there, to be honest. But nowadays, this is not unfamiliar to someone who's used almost any more modern language, be it Python or one of the newer languages like Swift or Rust or Go or whatever. It's not a surprise. So, all right. With that, let's change gears and talk about immutability a little bit. So one of the things that's come into the mainstream, like so many good things, it originated in functional programming and was a prisoner there for a while. It has now been liberated into the mainstream. Is immutable data, like programming with immutable data. That's now become a common thing. And if you look at, for instance, the Roslyn APIs, the way the public representation of syntax trees for C# itself, which all our tooling is built on, like C# is built in C# and it has a public API that exposes syntax and semantics as a data model. And that whole data model is immutable, for instance. It means that you get a snapshot of what code looks like at a given point. And if you want to talk about code that looks different, you can't mutate it. You have to create a new snapshot from the old one. Which sometimes it's a pattern that's sometimes referred to as non-destructive mutation. And also when it comes to wire data and so on, in many cases, people don't want to represent it as mutable data per se, but they want to be able to create new data from the old data and then post it back or whatever the interaction model is. And so C# started out as a traditional object-oriented language with a strong imperative underpinning, like programming is about mutating objects, So we've tried over the years to make it easier and easier to express immutable data models and to not be penalized too much for working in that sense. And we're taking more steps in that direction in C#9. So why do you want immutability? So let's say that we want this person-student data model here to be immutable. That's actually, yeah, that's fine. Well, one reason is you want to share it with someone else, but you don't want them to tinker with it, right? You want to sort of write protect your data. So if someone were to sneakily say person.last name equals Hanselman, to just use another Scott on my team, they can do that with a mutable object model here, and we might not want them to do that. So C#, as of I don't know, a couple of releases ago, we allowed you to have auto properties that are getter only, that still generate an underlying field, and it can still be set in the constructor and so on, but it can't be. It doesn't expose a setter. So that's an immutable object model, and that's great. Good if you can get it, but now, so it prevents the unauthorized hacking of the object here. But unfortunately, it also prevents initializing the object with an object initializer, which has become a very common, very beloved way of describing data. Like there's constructor-based initialization and there's object initializers, and they sort of both have their both have their proponents, and rightly so. But one of the downfalls of object initializers is if you want an immutable object model. I've heard of companies that mandate object initializers even for the immutable data structures, and then they sort of use culture. They use code reviews to prevent people from then subsequently mutating the supposedly immutable data. So we want to help with that. In C#9, we said, well, how about we introduce a version of the setter that's called the initter. So instead of set, you can have an init accessor. It's really the setter, but it's a special version of it that can only be invoked during the during an object initializer. So as soon as you reach the semicolon here at the end of the object, the end curly really at the end of the object initializer, well, the object is locked now. You can't mutate those properties anymore. And so now the object initializer is allowed, but the subsequent tinkering here is not, right? So we found the right balance where the object can be successfully initialized and then it is immutable. There's not so much to say really about init accesses other than they strike that balance. One thing maybe that we can say about them is that they let's try to make this a full property. Take that refactoring. So there's a backing field and then a init accessor here. Now you can see that they're written out. So init, you can certainly write your own. Doesn't have to be auto properties. You can write your own properties with init accessors. But one thing I can do with an init accessor is that I can mutate read-only state because I'm guaranteed that it will only be invoked during object initialization. You can see if I put set here, then this mutation will get an error saying, hey, it's read-only. But because I'm using the initter, it has the ability to mutate read-only state. So that's the main thing that we're doing for immutable programming in C#9, essentially. Well, that's the first thing. So any questions on initters or init-only accessors here? You sound happy. You all sound so happy. So then the next thing though is that, okay, so I can't mutate it, but I do. But so what do I do? Right? Let's see. That's a happy comment. Thank you. So how do I do things? What if I want to do what you said? What if I want to do the non-destructive mutation? What does that look like? Well, you have to create a new person. If you want to represent the state after the change, you have to create a new person that's like the old person, but with something changed. And that introduces another thing to C#, which is what we call records. So records are a form of class declarations. A record declaration is a class declaration. We probably should allow you to say record class as a modifier, and I think we will in C#10. In C#9 here, records are always classes, so we don't let you say class. We just let you say record. It's a class with extra bells and whistles. They can do everything that classes can do, except inherit. You can't cross inherit between classes and records. We may find a way to do that in the future. So once you started on records, they have to keep being records down your hierarchy. So a record, as I said, is just like a class. Nothing gets squiggled here or anything. But the thing about records is that they have value-based behavior by default. So what that means is a number of things. There's a number of new behaviors they get that let you treat the record more as a value, more as a representation of a snapshot of the state of an object rather than the object itself evolving over time through mutable state. Right. So the key to immutable programming typically is to think of the data as a snapshot of the world rather than more object-oriented, the object evolving over time with a strong identity around it. So records embody that value viewpoint on objects. And let's see how records enable the non-destructive version of this mutation here. So I have to create a new person, and the person has to be like the old person. Oh, equals. Has to be like the old person, but with the last name changed to Hanselman. So there's a new kind of expression in town, a with expression. This is a with expression. Take an old object, and it has to be a record in C#9. Records are the only thing that supports with expressions in C#9. And then you get a copy of it that you can apply a new object initializer to, and that creates a new object with the modifications that the object initializer did, and everything else copied over. So if we run the program,
No record stored by default on the stack or in the heap.
can you say that again, Kurt?
Where
sound
are
was a bit garbled.
stored by default on the stack or in the heap?
Objects are allocated on the heap.
Okay, so this is actually an object.
This is an object, yes. Records are classes, and so person here is an object, gets newed up from a class, and this news up a new person, essentially, how you can think of it. Copies over the state of the old one, and then applies the object initializer on top. That is literally how it happens.
Okay, great, thank you.
So if we display the new person also, let's try to see the effects of our shenanigans here. Add some buttons. Let's see what window this comes up on. Here we are. You can see I have two objects, Scott Hunter and Scott Hanselman. So the Scottness got copied over. That's actually so essentially now I probably wouldn't represent. I probably wouldn't use this to represent. Oh, I created another object just like the old Scott. Scott and Scott are actually very different people. They had separate lives. They don't share. They're not different points on the same timeline. I would probably, if I was doing this in a real program, it would probably more be to represent, for instance, that Scott changed his last name, and so therefore I have a new record of him with the new last name. But the old record is still around and can still be used. I can still have a record of something that was a fact about Scott in the past, and I can use those I can create diffs, and I can do rollback and all kinds of stuff that people do with immutable data models, because they are immutable and because you can have multiple snapshots around of the same logical object at any given time. So one thing that I should note about this with expression is that it's fairly smart. So let's say that we actually there's stuff like this in some functional programming languages, but they don't have to deal with inheritance. But let's say that we actually create a student here. Student happens to have a default GPA here. Let's give Scott the benefit of the doubt and give him 4.0 as the default. But I'm creating now a student, but storing it as a person. So down here in this with expression, the compiler doesn't know that it's a student. It only knows that it's a person. This could be somewhere completely different in the program where no amount of static analysis could flow the information that at runtime that's a student. So what happens when Scott Hunter is really a student? What is the Scott Hanselman object that we create? What does that look like? Well, let's try to run the program again. That didn't really help. Let me instead of calling display person, this is probably a good time to just use WriteLine instead, because one of the other things that records have, and I should have showed you that a little while ago, one of the other things that records have is that they have a value-based toString, which means that when you toString a record, you actually get a meaningful string rather than just the standard gobbledygook you get with other objects. So now we can actually remove the display person thing here, and now we're just writing out the objects, and what we see is that they print their type and the state of their properties. So you can see that the copy that was created with the with expression, let's see if we can have both of them on the screen at the same time, is actually retains the runtime type and the hidden state that was there, even the state that the compiler didn't know about where the with expression was, right? It's a virtual withing that happened. The copying that happens is actually the object itself doing a full copy of itself. So it works well with object-oriented programming. Does that make sense? So you saw the value-based non-destructive mutation with the with expressions, and you saw the value-based toString. There's one more thing that is also value-based, and it's an important one, and that's equality. So we change the meaning of equality to not just be reference equality, but to be also based on the value of the record object rather than its identity. So let's try to test that out by creating yet another person. Let's call it old person. And that's the new person with the last name changed back to Hunter. As long as I spell Hunter right, things should go well here. And now, if I write out, let's try to right line. Let's try to new keyboard. Sorry. Let's try to print out, call it what the result of calling the equals object.equals method on the original person that we had and the old person that was created by non-destructively mutating in both directions. There we go. And just to check, let's also print out the results of doing reference equals, which is guaranteed to give you reference equality, checking whether they're the same object, not whether they have the same stuff. Okay, so let's try run again. And what you see is that the two objects are indeed equals, even though they're not the same object, right? So we've overwritten equality in records to go through field by field, actually, and checking whether they are equals recursively. This is exactly, all of this is exactly the same behavior as you have in structs today, in a sense. Equality on structs is value-based. Structs also support value-based copying, by the way. So just like structs are real value types, these are reference types, but they have value behavior. They're sort of very inspired by structs, but retain their objectness, the fact that they're allocated on the heap, the fact that they are by reference. So they can point to each other, for instance. It's very hard to make a tree of things in with structs. You know, it has to be with reference types. So there you go. That's pretty much the value-ness of records, if you will. And again, the equality is smart. It checks even the parts of the state that aren't known. Like it's calling object.equals. It's converting these two objects and then asking them, what is your real equality? And the equality is virtual. It's based on the underlying types. They also, just for good measure, equality is also is not just supported by overriding object.equals, but also by supporting equals equals and not equals operators and all on all records. So all records support this, and it works the same way. So whenever you felt like you really have to write a lot of code, or you wish you could muster the effort to write all the boilerplate code to make objects behave like values, well, now you can. You just declare them as records and off you go. Any thoughts on that? Oh, I'm getting some reactions here. The team's reactions. That's good. Thank you. It's almost like seeing your faces, but not quite. So one of the things now might be a good time to talk about a C#10 feature or two. So I mentioned that records are a lot like structs. The copying that happens in a with is like when you assign a struct, it's always a copy. The equality is like the equality that structs support, even if they don't have support for the equals equals operator and so on. If you call object.equals on two structs, that's value-based. And the semantics of records is carefully tailored to be like the one in struct, so you don't get confused by differences there. Except it handles inheritance gracefully. So next question, of course, is what about structs and records then? So in C#10, we're working on allowing you to say record struct like this. And that's where it will be really useful to also let you say record class, so you can visually distinguish. Then class becomes the default, but not the only kind of thing that a record can be. So you can have a record struct, and what you get out of that is you get all the you get the equality operators, for instance. You still get and you get the nice toString. So you still get extra record behavior when you explicitly declare a struct as a record. Even if you don't declare the struct as a record, though, we plan to allow with expressions on all structs. Because all structs support copying trivially, it's easy for us to support with expressions. Just copy the struct using the same copy that we've had in the language forever, and then apply the object initializer on top. So we're planning on supporting that on all structs. And in addition, we're planning on supporting with expressions on anonymous types, which not all people use, but they're definitely in some areas, like when you use a lot of link queries and so on, object initializer or anonymous objects are used quite a bit. And they're kind of like anonymous records. They have value semantics as well. We actually reuse some of the same code there, and they will support with expressions in C#10. You have one anonymous object, you can with it and change one of its values and get another one. That's like the old one, but with the change. There's a question here. When using with, if you want to access the existing object before the mutation, I assume you can just use person in this case. I haven't used the with keyword yet. That's exactly right. So person doesn't change. It's non-destructive mutation. As long as you keep something pointing to the old object that was created here, that object remains and maintains its state. It's not changed in any way. And that's actually part of the attraction here, that you have you can have multiple snapshots that coexist. It's great for, like, if you look at Visual Studio, some of the refactorings, like I did a refactoring before, where I let's bring that up. Let's do a refactoring here. You can see there's a diff right here that is actually using not the with expression itself, because we don't have it in C# at this point in we didn't have it when we built this object model, but it's using the same techniques of using the before and after object, creating the after object from the before object non-destructively, and then diffing them to show the visual diff here. And actually, if I do the refactoring and then undo it, I am reverting to the old one, right? We're really using these techniques, and it's a common way to manage graphs, object graphs that evolve over time. If you look at some UI frameworks as well, they have some of this behavior to them, like the React style framework, for instance, where you create a new one, a new tree to render every time, but you might be creating it by by making subtle changes from the old one. And there's a diff going on that between the old and the new that then turns into the sort of net visual update that has to happen. So let me see. Oh, so there's more to the question before. Yeah, you can use the old object in the with expression here because it's captured in a variable. But I can't, like, one thing I can't do yet, and we might add that feature at some point, is I can't say, you know, grandmother.last name equals. I can't have dots on the left-hand side in the object initializer. So I can't do like deep change directly in the object initializer. What, if any, role will records play in entity framework? I think they're still figuring that out. Part of being an object relational model is usually that you track mutations. And so object relational models typically actually depend and rely on you mutating so that they can record the changes you made. And I'm not sure where they're at with their thinking about whether they should be a more immutable style, non-destructive approach to this. So unsure. Okay. Let me see. What did I do? Oh, it's all the struct stuff here. That's giving me all these squiggles. I want the squiggles to go away. Record. Oh, did I messed up the end of something somewhere. If anybody can see what is messing up my code right now, please let me know. Huh. That is strange. What else did I do? Record person. I think somehow this is where I should say that I'm running on a preview of oh, it went away. There we go. I'm running I always run on a very early dog food build of Visual Studio, even when I'm presenting, and that sometimes leads to trouble. But just wait long enough, and apparently the squiggles go away. Okay, so so one way that I've cheated a little bit here is in C#8. You know, we introduced nullable reference types, and I'm of the opinion that they should be turned on everywhere as much as possible because they help you with things. So I'm going to, but I haven't actually turned them on here. And if I do, some things will become evident. It's like, I get some squiggles here. I've turned on nullable reference types, and now I have these properties in my record, just like if it was in a normal class, nothing's different here, that are non-nullable, but they aren't initialized. They would retain their default value of null if I don't do anything. Now I do something up here, but I didn't have to. I wasn't forced to do it. And so there are several things you can say to that. You know, one of them is, well, you can just make them nullable. You know, maybe you don't require a first name. Or you could say, well, maybe there's a default last name. Maybe, you know, Doe is the default last name. So there are various ways that you can make the warnings go away. But what if I really wanted these properties to be mandatory, to be required, to not be optional? Well, with object initializers today in C#9, there's no way that you can do it. we are actually discussing, it gets a little complicated, so we'll see where it lands, but we are very seriously discussing allowing required properties in C#10. So simply a new keyword here. This doesn't work yet because it's speculative. You declare a property as required, and now you can't create it without an object initializer that initializes the required properties. Like, they're required, and we're going to require them. So that lets you kind of stay in the object initializer paradigm while getting out of them being forced to be optional, if you will. So that's in the bag for next time around. We don't have that yet. So if we want to require these, the recourse that we have is that we can use old-fashioned constructors instead. That has some downsides, but it certainly works. And you can still, like, records are no different. You can have a constructor here, public person, and now we could take these and forgive me for just copying the declarations in here. The reason why will be apparent a little later. So I can write my own constructor here that takes parameters and does something with them, right? So we could say this dot first name, comma this. Have you seen this shorthand before? I love it. This last name equals the two parameters. So using a tuple to turn multiple assignments into a single expression here. This is like this is candy for some, and makes other people run away screaming.
Can records be constrained to implement interfaces?
What's that?
Can records be constrained to implement interfaces?
Records can implement interfaces, absolutely.
Okay.
Yes. Yes. They're really not restricted in any way compared to classes, other than the fact that they can't inherit from other classes or be inherited by classes. So, but this is, this is a mouthful to write. One of the problems with constructors is there's a lot of boilerplate around just the body of them, writing them. So records actually, they allow a shorthand here that is that you can put if you want a constructor, you can put the constructor parameters directly on the record. And that means, and the record has a constructor that with these parameters, call that the primary constructor, because you can have more constructors as long as they call that one. So this is a primary constructor. Now, I'm not using the parameters yet, but I could be. I can use them to initialize the here you go. I can initialize the properties with them. So there. Oh, and I should have said last name here. There we go. So they're in scope for the initializers here, which is fine. So that gives you, that's a little more snazzy. You're writing the constructor parameters directly on the class. That's some functional languages let you do that. So, but actually, we go a bit further. So now let's go and have a look at the. Let's try to dot into one of the persons here. You can see the first name and the last name there in the completion list. What if I had followed the parameter guidelines and used lowercase names here? And now we have to use them down here as well. What happens to the person object? Well, now it has two first names and two last names. What's going on here? Well, what is going on is that in records, unless you have a property with or field with that exact name, with the exact name of the primary constructor parameter, then we will generate one for you with that exact name. So there's actually, so while this may seem a little annoying or dangerous, well, the upside of it is that that we will automatically generate properties for you that happen to be public, init only properties that are initialized from the parameters here. So if I remove these two property declarations, I still, if I go and dot here again, I still have a first name and a last name that just generated from the primary constructor parameters. You know, oh, okay. He doesn't want to declare his own first name. Let's declare one for him and initialize it for him. As a matter of fact, if that means that your record body becomes empty like this, we just let you put a semicolon there on the declaration. So this is a very shorthand of a type, right? It has properties, constructors, it's a record, it has all the value-based stuff, all wrapped into this one liner here. So that's kind of nice. But it also gives you all the downsides of being constructor-based still, which is that, well, okay, so now student needs to call this constructor. Okay, so maybe the student is also has a primary constructor, and you can actually put a call to the base constructor on the base class here. So I can deal with it like that, and maybe we leave the GPA optional here, and that's still something that you set with the with an auto property. So, but you know, if we wanted it to be its own non-optional, its own required thing, we would have to add it here to the parameter list. Like, you know what it is like with constructors, right? They grow and grow through your hierarchy, and it becomes a little bit brittle, right? If you want to add something at the top of the hierarchy, you have to go and change all the code all the way down. All the constructors have to carry this extra parameter, and of course at the point where you create it, you also have to supply the parameter names and so on. So constructors definitely have these downsides of brittleness and heaviness, especially around hierarchies. But on the other hand, you know, if you need them, it's certainly more nifty to have primary constructors that are this terse, and then in C#10, hopefully we will be able to figure out the required properties for when you don't want to start building these constructor change, even for properties that you want to ensure that the caller will initialize. So that's records. More thoughts or questions here? I think not. Okay. So hopefully you'll have some fun with this. Hopefully there'll be some projects where this is useful to you. I mentioned the potential C#10 feature of required properties. Let me see, and we talked about the record structs, which are also C#10. Let's maybe at this point, well, I want to show one more. Let's get back to where we can actually compile. Hang on. Let's see. Let's get out of the constructor-based stuff here. I'm just undoing a bunch of things. There we are. Now, let's just have a little look here. Let's say that I put I don't know why this is all highlighted. I don't know what I just did. Never mind. Let's say that we put student here instead. One little feature that was added in C#9 as well is the ability, when there's a clear target type, when you're creating a new object with new and there's a clear target type, then instead of writing like an object initializer is really like parens followed by the object initializer here. Instead of writing this, I can omit the type. So I can just say new. I need parens even if they're empty, because otherwise it looks like an anonymous object. And now the compiler will just take the student and stick it in there, right? So when it's just local variables, you know, whether you put var here and student there, or you do it the other way around, not much of a difference in like savings. But if you are passing a new object to something, then this can be and it's fairly obvious what it is. You're passing it as a parameter or assigning it to a property or something. This can be, like in here, this can be a very nice shorthand, especially when the type is a big one and it's obvious from the surroundings, like you have a generic type or tuple with names or something like that. Well, it wouldn't be a new expression then, but generic type with a tuple element type, let's say that. So there are definitely situations where it's nice to not have to say the type, but it only works if there's a context, if typing context that is clear and easy for the compiler to say that's the one they want. Let's stick that in there. All right. With that, let's go and talk about pattern matching for a bit. Oh, thanks for coming on camera, Brian. You're all hiding behind turned off camera, so it's good to see your face.
Likewise, thanks.
So let me head over to another file here. So pattern matching is something that we've evolved for a couple of versions of C# now. Started in C#7, and it's evolved its capabilities quite a lot in C#8, and we got switch expressions and so on. So we have a fairly full-fledged system around pattern matching now, where we had nothing prior to C#7. It's a whole new thing that's grown up in C#. And we can go into, you may have heard, it's been almost half a decade now with pattern matching, so I don't want to preemptively go into the whole spiel about them, but if you're interested in more of the reasoning about why we have it and so on, I'm happy to go further into that. Just ask the question. But here's an example, and it's one of the ones that you can find in our documentation. So it's a fairly, so it's one that you can go and play with. A toll calculator that there's a bridge outside of town, and commuters are passing the bridge, and they pay a toll as they go over, and it's automatically calculated and bills a cent. But what should they pay? This is the logic that decides what they should pay, depending on what kind of vehicle they are and various attributes or various aspects of the different vehicles, right? And we express that as one big switch expression. So the body of the calculate toll method here is an expression body. That's one big switch expression. Takes the vehicle and switches on whether it's a car, a taxi, a bus, or a delivery truck. And for each of those, there's one or more patterns that matches that type with more specifics. So for the car, we just take the car, call it C, and then we take the number of passengers and we switch on that. So it's a nested switch here that based on the number of passengers, 0, 1, 2, constant patterns here, we decide on how much should it cost. The more people are in the car, the less they pay. Great. For taxis, we do it a little differently. We use recursive patterns that were added in C#8, saying, hey, if it's a taxi, where the fares property matches the pattern 0. So recursive pattern matching on the fares property here. Again, they pay more if they don't have any fares, right? If they don't have passengers. And there's a fallback here with the discard, saying if it's taxi, we don't care what it's called because we're not going to do anything with it. If it's taxi otherwise, then they pay this much. And so in C#9, we have smaller improvements, but still useful improvements to patterns. One of them is you don't have to say this underscore here. If you want to say, hey, it's a taxi, but I don't care about the specific taxi, I don't want to ask it any more questions, so to speak, you can just leave it out. You don't have to put the underscore there. We also have another form of recursive patterns. Buses have a deconstructor, so you can take, if it's a bus, you can split it up into a C and an R, whatever those really are. And you can compute something from that in a when clause and pattern match based on that, decide whether the bus is full or empty, essentially. Delivery truck, it's based on the weight, and we have a bunch of patterns that use a when clause again to apply a Boolean expression to that. And this is another one that gets interesting because wouldn't it be nice if I could just turn this being greater than 5,000 into a pattern of its own? And so with C#9 you can. So we could say, instead of doing this, we could say delivery truck, and then we can see. Then we can take the gross weight class and we can recursively switch on that. And now we have what we call relational patterns. This is actually a legal pattern. Greater than 5,000 is legal. Less than 3,000, as long as they're constants, this is a valid pattern in and of its own. And then we can say for the rest of it, if it's in between, would be where you fall through to this third case of delivery truck. And you pay something in between. So relational patterns is the second new pattern form. The third one is, well, I actually want to express two relational patterns. Like I would like to say explicitly what's in the middle here. Maybe I want to express multiple ranges and so on. I want to be able to express a range that has both an upper and a lower bound. So what if I could say greater than or equal to 3,000 and less than or equal to 5,000? And I can, because we also have logical patterns where you can take any two patterns and combine them with and, or with or with not. So we can now apply logic to the patterns. So you might ask, why are you using the keyword and not the ampersands that are the sort of C-style way of saying and? And that's just because these are already expressions, and these are occurring expressions as well. And if I put this here, it would be very confusing as to whether it was part of an expression or whether it was combining part of an expression inside of a pattern or whether it was outside of the patterns combining them. It's confusing both for the compiler and for the reader. So we decided this is the place where we use keywords to further differentiate that you're not actually talking about ANDing expressions here. You're talking about ANDing patterns. Okay. So if I make it all the way down here, I could maybe apply a little not pattern and say, well, if it's not null is another new thing you can say now, right? Null is a constant pattern, not it negates the pattern. Not null, then throw not a known vehicle type, and otherwise it's null down here, and we would deal with the null case in this case. So essentially there are three new patterns in town, and we're thinking about the further patterns that we're thinking about. We'll see if it makes it into C#10 or list patterns. They're very commonly used in functional languages where you say, well, if the thing comes in is a list, then give this pattern grabs the first. If there is a first element, this pattern matches, and I get a name for the first element, and maybe I get a name for the rest of it, or maybe I ignore the rest of it. And this kind of list pattern is the next thing that we're looking at for pattern matching. For the relational patterns here, one of the questions you might ask is, why is this so much better than what you wrote before? Why is this better than Boolean logic? And part of it is that the compiler can check more things with patterns. Let's say that I accidentally put less than or equal to 4,000 here. Well, I get a warning saying that this switch here doesn't capture all values. It doesn't have a case for each possible value coming in, And it even gives an example. It gives a helpful example that if somebody, if the value 4001 comes into the switch, then it won't handle it, which means it'll throw an exception. So that that's a good way of getting more compiler help and making sure that your patterns are exhaustive. There's also the other way where a pattern is subsumed. Let's say that I say greater than 3,000 here instead. Well, greater than or equal to 3,000. Now this last pattern here never applies, and the compiler can also catch that and say, hey, you have a case that is never used for anything because everything is captured by the first two cases. So we have a fairly advanced analysis. Once you do a switch and once you use the patterns, the compiler can apply a very advanced analysis to checking that your cases are not subsumed and that the switch is exhaustive, and that's kind of useful. That's why we keep adding these patterns. Part of why we keep adding these patterns, other than just also the syntactic convenience of it. In the delivery truck example, you set the 5,000 value has to be a constant. It can't be a variable. That's true. One of the big places where we've held the line in patterns is that all patterns today are constant in a sense. They don't evaluate, other than the value coming in, they don't really evaluate user code. They're very careful not to call methods on the object coming in. They do call properties, but they generally don't evaluate user code, and they don't and so they also don't use the value of variables in the environment. And that gave us confidence that we could build an efficient implementation of it, and we could do a strong analysis and so on. But I think that it's something that we are likely to change at a later point. I think we're likely to allow variables from the environment to be mentioned in here. So let's say, if there's an int in scope somewhere, we could use that one here instead as part of the pattern. And maybe what we would do is we would capture all the values of all the variables before the switch starts executing, so that we don't have weird side effects where the switch expression somehow affects itself or something. I don't know, but it's definitely something we might go to later, but where this is a story that's unfolding over years and years, and we're happy to take one step at a time. And Andrew says, then it makes it more difficult when you want to raise rates. You'd have to change code, recompile, and redeploy. Well, that is not so much the case, because as you can see here, the patterns are used in the conditions. But as long as you don't want to change the rules, the expressions themselves don't have to be constant. It's only the patterns, like the expressions. Actually, both the expressions in when clauses, like this one, and in the result, they don't have to be constant. So you can definitely, if this 5M here is sort of like the base bus rate, and that sits somewhere else, and you change that, then that can get evaluated in place here. And so it's only the pattern itself that has to be constant. So it's not as bad as you fear there. There's a nice example down here. Here's a method that is an if-else. It's trying to translate the hour of the day, or it's translating the hour of the day into an enum value, right? So you get what time of day we're looking at, and that returns is this morning rush, evening rush, day or night, essentially, 4-value enum with an if-else. Now there's a light bulb out here now suggesting that I convert it to a switch expression, and if I do that, you can see it now uses the relational patterns nicely to write this in a much more legible way. If I want it, I think I like it this way, but just to make a it even clearer, we could say greater than equal 20 here is the overnight band, and now we have two overnights. So we could take one of them. We could merge them by using the OR. So I could say OR greater than or equal to 20, and now I'm handling both of the cases where we want to return the overnight value, and I can delete that one that was subsumed. You saw the red squiggle, and now I'm expressing concisely with a pattern the condition for each of these to take effect. But that's up to you. It's mostly just to show off the OR pattern. So there you go on pattern matching. And again, I trust that you will shout or ask or anything if you have more to say. There are a couple of things in this library that I want to, just because this is a library, I will, there's a couple of things, there's an opportunity for me to show a few more of the features we're thinking about for C# 10. So in this vein of simplifying code, making code simpler by default, maybe more approachable to beginners and so on, that you saw, like you saw with the top level statements. One of the things that we notice is that 99 point something, I think it might literally be 99.9% of the files that we look at have at most one namespace, and everything is in it. Okay. So everything in this file is in this namespace toll collector lib, and therefore everything has to be indented 4 characters or whatever your indent is. You waste an indent for the whole entire file, everything in this file, just so you can be in this namespace. What if we said for this 99.9% special case, we let you do a namespace declaration on top instead of like a namespace in curlies, and we let me just comment this out for a second, and we let you indent everything out to the to the top level, indent one level further out like this. It won't do it if I leave the namespace declaration in. So so now I'm just saying up here, the rest of this file is in this namespace, and now you just gained 4 characters of horizontal real estate and in every single file everywhere, right? So that's a simple, just syntactic sugar, but it makes life nicer. A similar thing is usings. It's kind of a tyranny of usings. Essentially, if you look at most files, they will have a lot of usings representing sort of the evolution of C# in a way. There's using system, then there's using systems.collections.generic, then there's using system.link. That's sort of like version 1, 2, and 3 of C# with each its own new library on top. And so it goes, and you're in some you're using some framework like ASP.NET. There's 6 or 7 things you also want to use in there, and that's on top of each and every file. We're ready to not make you do that, and to take all this using madness and squirrel it away somewhere. And the way that we're thinking to do that is to allow a global using declaration. So somewhere in my project, I can say global using system. And that means that every single file in this project now has system in scope. It's using for all files. And we're still talking about what kinds of best practices there will be around this. I think that it's likely that people would have a dedicated file with a global usings in it. So, and maybe there's going to be a naming convention for that. So we'll think about what we'll recommend there, so that there's just one place where your global usings are. It doesn't prevent a file from having, it's doing some special stuff. It's using link, but the rest of the the file isn't, so it's using that or so on top of that. But global usings gives you one central place. We could update the templates for ASP.NET and so on, so that they put the things that you'd want to have access to, put them in one place instead of spread all over. We could maybe have refactorings that take you between the two models and so on.
How often do you think it happens that the whole group of classes in a library will use the exact same set of using statements? And I'm specifically wondering, I use ReSharper, and if I if I refactor the code so it doesn't need something, ReSharper complains, and I like to neaten up the code so I don't have any unused usings in there. Did you think about that issue?
We did, and in a way, we think there's sort of like there's a tyranny here there's a neatness tyranny. There's sort of like as you move your code around the tool, and that's not just ReSharper. Like we do the same in Visual Studio by default. Is that we gray out your unused usings, and you're kind of being nudged to clean that up and take care of that. And that's actually, like, in a way, that's counterproductive. What do you get out of cleaning those up other than saving a few lines on top, right? What you get out of it is very, very rare benefit of, well, these names aren't in scope. So what exactly? So there's a collision that I avoid or something. It's not very useful to have fewer usings. It's just, I mean, very occasionally useful, but it's not very useful to have fewer usings. But somehow we're making you clean this up all the time. Remove unused usings. Oh, damn, now I need it again. Now I need to put it in again. And it's just like a little hamster wheel thing that we're making you do. And if we thought of it differently, rather than being this thing that you needed in every single file, and it's always in your face, but it's over there in a file, and it's all the things that you might want. And it doesn't matter that you're not using some of them right now. They're over there in this other file. They're not in your face. They're not bothering you. Maybe we should not gray out the ones that you aren't currently using, so you won't be tempted to take them out.
Maybe I should change my thinking about that, huh?
I think that we are changing our thinking there. Yeah.
No,
I think that
me,
that?
not you.
Oh, I changed your thinking. Well, hope that's a good thing. And Nathan says, so this is, someone's asking, is this C# 9 or 10? This is C# 10. It's not there yet. So you can still influence us here. And Nathan asks, it would be great to see global usings per namespace too. So you mean like the usings that are nested inside of namespaces? We had actually not thought to make those global. That seems like more of a special case, but we might be convinced. It might be one of those. Here's the thing: we're releasing C# every year now. Like as of C# 10, that'll be the first time C# ships on a yearly cadence. Like, well, I guess we did a year ago as well, but that was the first one. So it's only a yearly cadence when the next one comes out a year after. And so we have a pretty rapid clip of C# versions coming out. And so what we'll often do is if we're in doubt about something, rather than hold the whole feature till we figure it out, we'll be like, is there any danger in releasing the good parts of it now? And if we say no, if we can't see any danger, then we release something. So we might do global usings only for top level usings now. And then if people come and say, oh, I have this scenario and I have this scenario, and we're like, that actually makes sense. And we should actually figure out what it means and how global usings are shared between the places where that same namespace is declared. We might just do it in the next release. Yeah. So that is, go ahead.
I said it's a good answer. It makes me happy.
Glad to hear it. So that kind of simplification. And this is actually something that would be good for C# at any time. But we do have a for this coming version of .NET 6, we do have a focus. We do have a theme of looking at simplification up and down the stack. There are also non-language ways that working with C# and working with .NET is more complex than it should be. It's more complex than it is with other stacks. And we're trying to look at a number of ways that we can simplify that experience. Like, for instance, one thing you can't do in C# today is just have a C# file and run it. You can't just have compile and run a C# file. And that's like so last century. And most languages let you start there, and then there's a grow up path from that to having projects and that whole machinery of keeping track of many files in a structure. But we're trying to think through how we can better capture the beginner end or the simple end of that spectrum, how we can, without having some kind of cliff that you need to jump to then get to full project support, and how we can also bridge some of the interactive stuff that we've done. So I can't say yet what's going to come out of it exactly, but suffice it to say that there are many simplifying efforts that we are looking at across the board here. One of the places where we want to help simplify that the language can also help with is less syntactic sugary than these and more semantic, actually. I don't have a good file where I can well, I guess I can go back to my main program and do something random. It's around Lambda expressions. So Lambda expressions are actually in many ways kind of clunky. They rely on, okay, so C# has this, we have this thing called delegates that goes all the way back to C#1. And delegates, so we have, now we have a library of generic delegates. So we have func of int here. Actually, I don't, because I need a using. Func of int f equals some function that returns an int. Okay. Now, delegates, first of all, delegates they're a clunky kind of function type anyway. But also, in order to use a lambda, I have to convert it to a delegate type. I can't just say var f equals and a lambda, right? Lambdas don't have a natural type in and of themselves. They need to be given one. A lambda expression has no meaning until it is converted to a delegate type, or an expression tree type, by the way. And so that's kind of, why couldn't we, now func and action have been in the library now for over a decade, I think, and at least in up to a certain number of, a certain arity. Why couldn't we just figure out, well, why couldn't we just pick func of int as the type for this thing and infer that in the variable here? That would be really nice. And okay, if we go beyond the number of arities that are represented in the system library, or if you want to use refs or something else in the signature that they can't represent, well, then we could just generate one that's called func, or that looks just like the other ones. We just generate a delegate type for you, and that would not just like make C# simpler in general, but it would also help the ASP.NET team, where you sign up callbacks and so on. It would help them in various ways simplify their API surface area, where you don't have to say that delegate type all the time. So that is something that we'll probably do in C#10, again, as part of a divisional effort to simplify, where we're playing a supporting role in somebody else's work to simplify their surface area. Okay. Let's see. We have 15 minutes left of scheduled time. I'm sort of at the end of what I can show in Visual Studio. And if you want, we can go and and pluck around a little bit in slides and see what goodies I can shake out of there. There's actually one feature that has, I don't want to get your hopes up and saying it has a high chance of making it into C# 10, but we're working on it in the C# 10 timeframe. It's more likely, I think, that it'll come out in a, actually, can I?
Are you going to talk about UI at all? Maybe I made a mistake on the content of your talk.
About UI as in UI frameworks?
Yeah, like Maui.
I don't have enough background on that to really speak to it.
Kurt, that was last month's session.
Oh, okay. I'm sorry, I got confused.
Yeah, no worries. I think it's cool, but that's pretty much the extent of my knowledge about it. I'm just trying to see how I can get. Just hang on. Just get to the right part of my presentation here. So one thing that has always been a bit of a pain, and that more and more languages are getting better and better at, and so again, we're feeling a competitive pressure here, and also some juicy scenarios around, is numerics. Okay, so .NET is not super fantastic at numerics. We do have advantages over some other older languages in that at least we have operator overloading. So you can write, you can declare your own type to have a plus operator and a star operator and so on. That's good. That's something. But what you can't do at all is abstract over that. You can't abstract over it and say, hey, everything that has a plus operator is welcome here. Or you can't write a generic algorithm that takes things and that takes t's and adds them together or stuff like that, right? So there's no way of abstracting. There's no, for instance, generic abstraction over numerics in C#. And we've actually had ideas for how to deal with this lying around for a long time, and now we think it's time to act on them. And the idea that this all comes down to is that we want to start allowing abstract static members in interfaces. Okay, so I want to allow an interface to say any class or struct that implements me needs to have these static members with these signatures. So because one form of a static member is an operator. Operators are static members, and we could have interfaces that, like this one. I call it monoid because a professor once told me that that's the mathematical object that this represents. I should probably just call it addable. I could have an interface that describes things that have a 0 element, a neutral element, and a plus operator, and they are addable things. I could represent that with an interface if I could just declare static abstract members in interfaces. Now, if I do that, then I could go say, okay, for instance, all our numeric types that are built-in types or inherent, what you might call them, primitive types in C# that have numeric capabilities, they could then implement this interface. This would be an interface that we stick in system, and we just make all our numeric types implement. And they would implement. It already has a plus operator, so the plus operator could implicitly implement the interface member. Maybe we don't want to expose the 0 static property on int directly, so we do an explicit implementation of it by saying, type dot something, just like we do with instance members. So now I've implemented the interface on the interface on a useful type, but user types can also implement this interface, and so everyone can share this abstraction saying that they're addable. Now I can write a generic method in terms of that abstraction. I can have an add-all that takes an array of t's, where t is a type parameter that's constrained to being an addable thing. And that means whichever type comes in here, it has a plus operator. and it has a static 0 property. And so now I can have an accumulator variable that takes the 0 property and reaches over the elements and pluses them using a real plus, and returns the result. And now we have genuine numeric abstraction. I can then go and call this method on anything that implements a monoid, like an array of ints, for instance. Int becomes the t, and t satisfies the constraint, and the pluses become mapped to pluses and int. Furthermore, as soon as we talk, so this would give you numeric abstraction, and that's beautiful. But people often worry about performance when you talk numerics. And but the nice thing is that at least the core runtime routinely specializes generics when you pass a value type as a type argument. So when I pass int, it's implicit here, it's type inferred. When I pass int as a type argument here, it will actually generate a specialized version of this method at runtime where it substitutes int for the t here, or int32 for the t all the way through, and does whatever optimization it can on that. The JIT will do that, and the same for double and so on. They will, whenever you use it anywhere, there'll be a generic specialization of it happening as part of the JITting. And so that means that the JIT can do all the same optimizations as it could if you had handwritten a method, a version of this method, painstakingly doing the same thing for each and every type. And if you think about system.math, for instance, today, it has a bunch of methods that have like 10 overloads for all the primitive types, where you can imagine the implementation of those methods, like max, for instance. The implementation of those methods is exactly the same. You look at the source code and it's exactly the same, but they have to be handwritten in order to apply to each and every numeric type. What if we had a generic implementation of all of those that would work not just over the built-in types, but also any user-defined types, whether we implement them in some special libraries or you implement them and whatnot? There would be a max algorithm just waiting for you to call it, a generic one, just waiting for you to call it on your own types. So that is, I think, something that's very promising, and we're currently working, and we started up a collaboration. This requires runtime support, right? So we started up a collaboration between the runtime team that needs to enable this thing in interfaces, the language team, which is us, the compiler team, to implement the rules around it and the syntax, and the library team that will take advantage of this for numerics in various places. So that I think is very promising. This is the first time in a long time that we add a new abstraction mechanism, if you will, or we expand the way that you can abstract things in C#, and I'm quite excited about it. I think it's the first step. I'm not going to guarantee that we're going to make a gigantic multi-release numeric push, but maybe someone else will. It's an open source world, If we expand the expressive capability of the language and the core libraries here, who knows what can then grow on top? Right now, the expressiveness is too restricted, but hopefully this will open up for more things to be possible. So C#10 timeframe work, but probably not a C#10 RTM feature. Maybe it'll be in preview in the RTM compiler. That's what we're currently trying to suss out.
Couple questions. I've heard different opinions on why static elements were not included in the original capability of interfaces. Do you have a definitive answer for that from Microsoft's point of view?
Well, I think that we understand what it would mean, and we think that is a reasonable meaning.
Okay.
In a sense, the way that you're seeing me using it here really is that there are constraints in generics that you want to apply constraints that aren't about the instance members. You want some way to have a constraint that says, I have these operators and these static members, for instance. There are a couple of paths we could then take to give you that. One is to have some sort of structural mechanism where you can, right here in the declaration, you can list all the operators that you want to have available here. That becomes tedious fast. And the next thing people are going to ask for is, can I name this group of operators? Can I please give them a name? So the next step is, okay, there's a way to declare constraints, sets of constraints with names. And now should named constraints be a separate thing in the language, or should it be an expansion of what interfaces can do as an existing mechanism in the language? And we think here it's better to stretch interfaces to the scenario rather than introduce a separate mechanism.
Yeah, I think that makes perfect sense. But getting back to your point about a whole bunch of different interfaces on the right side of the T, why couldn't you just aggregate the interfaces and inherit by a single interface? That would give you a grouping.
Right. And so I'm not saying that this particular interface is the one that we should have. This is just a toy example. Right. And actually, one of the biggest challenges we will have as we build up this feature is designing a good, long-lasting, robust, useful interface library of numeric types. Like that requires some deep thinking and some studying of scenarios and so on. That won't primarily be my job, but I will be involved in it along with the library team, especially the library folks that work with numerics a lot. Where we don't want to have a vast proliferation of sort of ad hoc number interfaces. That would be bad. Like, which one should I pick? Should I pick the one that has plus, minus, and star, or should I pick the one that has plus, minus, and division and 0? We don't want to have that kind of wilderness situation. We want a well-designed, structured hierarchy of interfaces. We believe it's possible because we've seen it in other languages. So while we're probably not going to steal their hierarchy directly, we can at least take heart from the fact that they were able to do it, and people seem happy with the outcome of that. We could probably do something similar, where maybe there's a family of 8 to 12 interfaces that together express most of what you want to say, most of the shapes of numerics that you'd want to be able to use as constraints on generic numeric algorithms. So that's work. I won't even say in progress. That's work ahead of us. And we could probably ship the language feature in C#10 without maybe being done with the library work, or we potentially could, but I don't want to do that. I want to make sure that we co-develop the language feature and its most important scenario so that we don't do anything in the language we regret, and so that, we understand the full picture. We have this chance to collaborate across the stack, and we're probably going to finish it all at the same time. Just like with Link, back when we did that, the libraries and language shipped in sync, and that's happened multiple times since.
Mm-hmm. Another issue I'm sure will come up in a method like add all, would it be possible to escape the overload of the plus operator within that method if you wanted to use it mostly everywhere, but there's a place in the method where you wanted to revert to the old operator, the default operator?
Well, typically the default operator wouldn't even be available, right? Essentially, there's no on T's, right? It wouldn't be available on T. This specifically overrides plus on T, the type T, or it brings in a plus on the type T, where type parameters don't have a default plus today. There's just no way that you can plus them unless you know exactly what type they are, and then they're not type parameters anymore, right?
I get it.
So they won't be shadowing anything. There might be a thing where if you have multiple interfaces, each bringing in their own plus, there might be ambiguities that could occur. That's one of the things that we have to design for when we design the interfaces, right? Okay, this one brings in a plus, this one brings in also a plus, but it has a different return type. Okay, which one, now we have an ambiguity. Which one do you want? So there might be some issues there, but there's not shadowing of existing behavior here. Now we're at 8 p.m. your time, and I've made it through essentially everything that I hope to show. I have one more thing that is further out that I can blow your mind with, but it's not so much a plan as something that's being investigated. And I can show that if you want, and I can also hang out a little longer. But I do want to acknowledge that this is the time I advertised in the beginning was the end of the meeting. And so if you got to do something else, this is a good time for me to say thanks for coming and thanks for the great questions and for hosting me. It's been awesome to be here. But I'm going to stick around a little longer. So just wanted to say that before you run off. What's that?
Who could resist something mind-blowing?
Well, hopefully I can blow your mind. Let me, again, I don't want to leaf through a bunch of irrelevant slides here, but let's, yeah, this is the one I want. Yes. So here is that same thing again with the static members and interfaces. So we talked about this problem about maybe there being a multitude of interfaces, and how do we make sure that all the interfaces that apply are being used in the right places and so on. And in general, not just in numeric context, but very much in general, there's often this problem you have where you want to adapt. You have maybe a framework somewhere that exposes some interfaces, and you have some other types over here that are their own class hierarchy or whatever, and you are a consumer of both, and you kind of want to fit them together. But those classes don't implement those interfaces. They just don't. In order to implement an interface in C#, you have to implement it where you declare, right? But what if I wanted to adapt between the two? Is there a way that I could do that more seamlessly and with more sort of like semantic transparency, if you will, or elegance? So I'm just using this numerics and static members here as an example of that. It's not strongly tied to it. So an example here is, let's say that I have very many interfaces that int could implement, but actually the people who wrote int, they don't have those interfaces. I have them, or somebody else wrote them independently, but I would really want them to apply to int 32. Maybe I could say that in my, I could sort of have like extension interfaces, just like we have extension methods today. Maybe I could say that in the scope of my code, I want this imonoid interface that somebody else wrote to apply to this int 32 that certainly someone else wrote and not me. I want it to be as if this class implemented the interface throughout the scope of this extension. Like I bring in an extension, instead of just an extension method, I'm bringing in an extension interface implementation, if you will, along with maybe extension properties and extension everything. It's a vast generalization of the extension notion, if you will. So now I'm saying that as far as I'm concerned, int does implement imonoid, even though the people who wrote the standard libraries never heard of imonoid. And therefore, I can call addall with int, and it'll satisfy the constraint because I said so, and I told you exactly how it will do so. The extension says how to map between the underlying type and the interface. It says this is how 0 is implemented. Plus is implicitly implemented because the underlying thing already had a plus, and so on. And now I get to call addall on int 32, even though it's written in terms of an interface that int 32 had never heard about. It's kind of crazy, right? But the general idea here is to allow more decoupling, and allow more elegant adaptation between things that don't know about each other. And hopefully we can figure out all the nuts and bolts of this. I'm certain that it will require quite a lot of runtime support. And so it's not a small feature. And yeah, it's going to take a while before we get a handle on this. But it's one of the kinds of things that it's fun to explore further out into what could we possibly do in the future that could really have an impact on, you know, software engineering practices even. And with that, I want to see if there are any more questions or thoughts broadly around C# and the language and evolution and whatever's on your mind.
You did a great job explaining this. Thank you very much for giving the presentation.
Thank you. My pleasure. Anyone else there? Did I miss any questions along the way? If so, please bring them up again.
Okay, folks, last chance for questions.
If you think of something later, don't hesitate to write to me. mads.torgersen@microsoft.com. It's straightforward. Just poke me. Sometimes I'm also responsive on Twitter, but that's more of an, I have more of an on and off relationship with Twitter.
Also, for anyone who joined late, we did record this, and this will be up on our YouTube channel, so you can catch any bit that you missed by coming in late.
Cool. Well, in that case, once again, thank you so much. Pleasure being here. One day, I will be here for real. We'll all be together in a room, and we won't even be scared. I look forward to that.
Thank you very much, Mads, for presenting tonight.
Take care, everyone.
Thank you.